Hi, my name is Gray Juba. I am an OT data and community specialist at FlowFuse. My background is on automation and controls and manufacturing. I did programming PLCs, mainly in discrete manufacturing, and kind of gained my experience in many different kind of fields as a system integrator, as a customer, and then graduated my life up into the data and analytics space, wrapped around into cybersecurity, and then decided after spending some time using Node-RED around 2016, I said, this is a great tool, and I'm really excited to kind of bring this to a broader audience. But less about me and over to Kadzai, our guest today.
Thanks, Gray. So yeah, my name is Kudzai Mandi Teresa. I'm based out of Germany. I'm a developer advocate at HiveMQ. So basically what I do here at HiveMQ is I do all of the evangelism around smart manufacturing, and that includes the unified namespace. And I'm also the founder of Industry Forward TV, where also I do a lot of evangelisms and educational content around the unified namespace and smart manufacturing and all the likes. So I'm excited to be on this call today and looking forward to a really interesting session here with Gray. So thank you for joining.
Absolutely. All right. So the agenda today, we just did introductions. We're going to give a little bit of overview of Node-RED and FlowFuse if you're kind of joining and kind of new to it. And then we're going to jump into ISA in 95 and the unified namespace. And then we're going to give a little bit of a demo about how deploying and managing the unified namespace with FlowFuse and how the benefits can come from leveraging the tool leveraging Node-RED with FlowFuse, and then again hosting a questions and answers at the end. Please again add the questions and answer to the question and answer box and leave the chat for just general discussions. So what is Node-RED? Node-RED was founded, or it was founded by our CTO, Nick O'Leary, in 2014 while he was working at IBM. It was open source shortly after. It's been around for about 10 years. There's approximately 4,600 integrations plus. And that's really kind of what brings Node-RED into the community and why you see it often a lot of different and various applications is that it has that extensive capability leveraged by the open source community to create integrations with things that are needed by the imagination and by the community. There's roughly a 500,000 monthly downloads on Docker alone. So we have a strong use case of people leveraging and using it across the industry. And today we're going to be kind of focusing a little bit on the manufacturing side of things. So we'll be kind of thinking about MQTT and the integrations with some of those devices that are on the OT side, whether it be, let's say, Modbus TCP or maybe a serial communication with those devices. So, FlowFuse was kind of after a couple of years of, after some time, our founder, Nick O'Leary, went around the community and basically, our CTO, Nick O'Leary, basically went around and was looking at a lot of the getting kind of user information about how Node-RED is being used. And it was founded in 2021. And FlowFuse is an open core platform. So what we have here on the right hand on the screen here is the platform in which we use to deploy Node-RED in multiple different environments. So one of the things that we see is the desire to be able to manage all of your Node-RED instances from a single, let's say, authentication portal. Whether that's your devices on the edge or those are instances hosted in the cloud, whether it be on-prem or within your own hosted environment or within the FlowFuse platform. And so the three things we kind of focus on here at FlowFuse is the operations and maintenance, developer velocity, and security and compliance. So we'll get into more details about the FlowFuse application when the demo comes, but just kind of want to give you a framework about how the devices, and when we think about ISA 95 and we get into kind of like the structure and the locations, where these devices will particularly land. Are they going to be landing in the lower levels of the stack, in the medium levels of the stack, or let's say the cloud level? And each of these different types of deployment mechanisms of the FlowFuse environment, we'll dive into those in a little bit. But for now, we'll pass it over to Kazai.
Okay, thanks. Thanks, Gray. So yeah, I mean, just before I jump into my part of the presentation, just a few words here to say that I was really early with Node-RED, just after it was really founded, and there was no doubt in my mind at the time that this is going to become an important technology in the industrial space. And I mean, unfortunately, back in the days, it was still frowned upon to kind of like be seen using Node-RED. So that's why I'm so excited about what FlowFuse is doing, because now we're really starting to see Node-RED really being implemented in enterprise applications. So as you will see, the demo that Gray is going to show a bit later on. So my part of this presentation today is to really kind of like lay the foundation of the unified namespace. So because I believe it is important to kind of like be all on the same page and understand the fundamentals of what the unified what the unified namespace is, and what role that Node-RED plays in that architecture. So I guess a good place to start really is by kind of like looking at this pyramid that most of you on this call would certainly be familiar with, which is kind of like just a segmentation of the different systems in the manufacturing environment. This is kind of like the status quo or the traditional approach to organizing information. And still to this day, we have all the systems are organized in this manner. So as Gray mentioned, you also see how you are going to be able to then deploy different instances of Node-RED based on this arrangement that we currently have on the shop floor. So now with this current setup, because basically the goal with digital transformation, smart manufacturing, or industry 4.0, whatever you may want to call it, is really for manufacturing to become data-driven companies. And the way that you do that really is to unlock the data that is logged at the edge, which is typically the OT environment, and then be able to integrate these two with your IT environment. So this then opens up the opportunity for you to start using advanced analytics tools like your AI models, ML models, to then start to actually perform increase the performance of your operations by bringing in these advanced capabilities of monitoring your data, which currently is not the case, or in most manufacturing is not the case. And the current approach to doing this integration is really this kind of point-to-point integration, where you've got your PLCs and your production equipment at the shop floor that is directly integrated to a SCADA system, and SCADA system is directly integrated to MES, ERP, and so on. So what is currently happening is that a lot of manufacturers are continuing with this trend of integrating just by layering on top these modern tools, as it were, as far as arranging them in this approach, just by connecting them directly to these different devices and systems, sort of like creating some siloed approach to addressing some data use cases. And this has got a lot of disadvantages. First of all, is the fact that this is a costly exercise, because what that means is that you need to bring in a group of experts, obviously, to perform that data integration between these different levels. And it typically takes a long time. So it takes months just for you to set up a connectivity infrastructure. In some manufacturing facilities, it might even take years just to get the data out and then start to experiment with it. So you don't want to be in a situation where it takes you months for you to even try a data use case that you're not even you don't even know whether it works or not. So what you want to do is you want to be able to prototype faster and be able to try the different use cases. And also, the disadvantage really here is that there's a lot of replication that is involved in this kind of data integration. For example, say if you've got predictive analytics use case. So you set up your connectivity infrastructure, you get your data out, even if you do that after months. Next time you've got, say, an energy efficiency use case, if you need to get data out, you repeat the same exercise of going through to collect data from all these different systems. So it's a repetitive and the costly exercise, and it's really so slow to move and be able to become a data-driven company. So that's why a lot of companies are not really finding value in some IoT applications that they deploy because it takes long for them to realize that value. So again, if you manage to create this point-to-point integration, what it ends up resulting in is this kind of spaghetti architecture where you've got these systems that are directly connected to shop floor production equipment. So this is a very complex architecture, which is really difficult to manage. It's not an open architecture, and it's really makes it difficult for you to build your data-driven use case on top of this architecture. And we've really seen, especially for customers at HiveMQ, we've seen a lot of companies that start down this path of say, okay, I just need a data use case. I can connect up to this application. That's all I need to do. But as soon as you start to scale and start to address a lot of different use cases, this is where it becomes a challenge, where you find yourself having some proprietary interfaces that need some dedicated manipulation as far as you need to get your data out. So this is then brings us to this concept of the unified namespace. So basically here, the idea is that instead of having these direct connections and all these repetitive connections to your connectivity infrastructure, this idea of bringing in different experts to connect different systems for you to start getting the data, what you need to do is to set up a data infrastructure where all the different systems within your manufacturing environment, they participate equally as nodes within that ecosystem. So if you need to get data out, all the systems, what they do is they push this data into this central hub of information where a common technology of accessing this data is made available. So basically what you're doing is you are contextualizing all the data from the different protocol interfaces, from the different data formats, from the different system configurations into this one unified access that is only accessible through a single interface. So just imagine if you had a data use case that required you to connect up to 100 or 1,000 PLCs or different systems that contain the data that you're interested in, instead of you setting up and maintaining all these different connections just to get that data out, all you need to do is to connect to that one single interface, and you get all the data that has been semantically organized, that has been contextualized, and you can then be able to build your use cases on top of that data repository. So how do you build that data repository? MQTT is a technology that allows you to then make data accessible in a way that is uniform and in a way that is actually gives you a single access point. So MQTT has got a topic namespace. So we're not going to go into details about how MQTT works, but basically it has got a topic namespace that allows you to organize information in a semantic hierarchy. So however your organization is arranged, you're able to then get data out of these PLCs, as you will see later on where Node-RED comes into the picture, being able to get data out of these PLCs that expose information in various protocols, publish it into this centralized location, and then make it accessible by all the other systems from OT and IT in a unified way. So as you can see here, you've got OT, IT, and it doesn't matter whether it's Sparkplug, which is the specification that is on top of MQTT, or whether it's through flat MQTT, you still get all of your data in a centralized source of information. So this is kind of like the whole concept of the unified namespace. Then you're able to address all the data use cases without having to worry about what servers lie behind that data, how many connectivity interfaces you need to replicate. So you're effectively shifting the rate at which you can address data use cases from months to days or even hours, because the data is there, ready for you to start acting on it. And it's also in a semantically understood arrangement. So what is the actual makeup of the unified namespace? So I mentioned that MQTT, which is effectively an MQTT broker. But the MQTT broker, what it does, it holds that snapshot of the unified namespace, those current state and events, all this information that you're pulling out out of all these different systems, you're publishing it into an MQTT broker and make it universally accessible at any given time. But that data, it's of no use if it's just being published as it is. So if you're pulling data out of PLCs and the naming convention is different and there's no context to the data is not normalized, you've got data in Fahrenheit, some of it in degrees Celsius, all of this is meaningless, even if you do manage to bring it into this central repository. So what you want to do is to be able to get this data out, contextualize it, and then make it make sense for other systems to be able to consume and readily make use of that data. So that's why the unified namespace at the very core is a combination of the MQTT broker and a platform that allows you to perform all these different data processing, which includes modeling the data, contextualizing the data, and transforming the data. So as you will see, this is basically where Node-RED plays a big part of not only just connecting to PLCs and different systems and putting the data out into a central repository, but also being able to subscribe into that repository and contextualize the data and republish it back so that it's ready for consumption by other systems. Now, this is how it looks like at a high level. So obviously, as you would know, not all systems are able to talk MQTT out of the box. There's still a lot of systems that don't support MQTT. And so that doesn't mean that they don't get to participate in a unified namespace architecture. So in this case, this is where you need to have a gateway. So a gateway, this is where typically FlowFuse would sit, performing the protocol conversion between legacy systems and then publishing it on the other end in MQTT formats, and then also performing the contextualization of the data by getting the data out of the unified namespace and republishing it back into the unified namespace. So again, as you can see in the unified namespace there, this is where you then get to arrange your data, because also if the data is not arranged in a semantic manner, it is also very difficult for citizen developers or people who are not necessarily data scientists to find the data that they're looking for and be able to make sense out of it. So once you are able to semantically organize it, it makes your data useful to everyone within your organization, which is really one of the big advantages or one of the big drivers of the unified namespace, to be able to make data accessible to everyone within your organization in a way that they can find it easily and understand it. So this is just to give you a picture of what that a typical arrangement of a unified namespace looks like for a company. So for example, if you've got a bottling company there, you see you have got a hierarchy where you've got a site that is in Munich, and then within that site, you've got different areas where you're doing your production. So you're able to publish this data as events into all these different buckets of information where it makes sense for that data to live. So if an MES system knows, if an MES system needs to perform some functionality or do some calculation, it knows where it needs to go to get data to perform that calculation. And also it knows where it needs to publish all these metrics back for consumption by other systems. So you've got this semantic structure that makes it easy for all these different systems that don't know anything about each other, don't know each other's IP addresses. Doesn't matter whether it's OT or IT, but they're able to find all of this information in one central location. So again, as you can see there, we've got FlowFuse or Node-RED playing that central part of being able to convert from your legacy protocols into MQTT and then be able to subscribe from that information and republish it back. So this typically follows an ISA 95 common data model, and you're going to see shortly how the arrangement of these different Node-RED instances are going to look like in this ISA 95 arrangement. So with that, I'll hand it over to Gray so that we could maybe go into the demo.
Perfect. Yeah, and if you wouldn't mind, I'm going to go ahead and share my screen again. All right. Where is it? There we go. So one of the things that you brought up that I forgot about is I think about that whole citizen development aspect of things, and I forgot to mention it earlier, and how that comes into play, and that really ties in right here. So this is the Perdue model. We're going to talk about it. There's a lot of different views on it's obsolete. We shouldn't use it, but I think that at the same time, there's still a lot of value we can gather from that because it really helps put context around where things live in the space. And the negative side is we're looking at something that's very much in alignment with like a discrete manufacturing place. Um, so that's why there's things like the ISA 95 that's a little bit more fluid and can work with different environments to kind of create data models that work better because a lot of the times the Purdue model doesn't necessarily always line up and isn't consistent, let's say plant to plant, as far as going from a physical structure. But it's still good to kind of identify and educate people that may not be completely familiar with, let's say, automation controls, but do know, let's say, MES side of things, or they know the ERP side of things, and they kind of want to get an idea of where things live and how things kind of transform. And this is why I personally like it for especially saying where should Node-RED sit with FlowFuse deployment. So let's talk about the different levels real quick and kind of dive into why those different levels kind of exist. And so one of the things that because I was mentioning was communication should only go from level to level. So, for example, level 0 should communicate to level 2 and above. But that's one of the things that have changed with this ISA 95 and unified namespaces. Now, when you bring in things like the MQTT broker, you now have a clear pathway for allowing communication across those different levels. But let's start from the bottom. So level 0 is your field network. So this is going to be, traditionally speaking, especially on those legacy devices, these are going to be things that are not of your physical layer of Ethernet. It's going to be your Modbus, EtherCAT, Profibus, device net, things that just don't look like Ethernet that are used for communication on those devices. And this is, again, this is generalized. Sometimes there's different use cases, but it's that communication between the level 0, which is going to be like your robots, your motors, your conveyors that helps drive your manufacturing process. And each of those field buses have their purpose, whether it be to speed and connectivity, whether it has to do with specific data points, but that's where the purpose is. So when you see in level 1, that's when you do that first transformation. You're going to be converting data from different structures into your MQTT broker. Whether you're going to be sending that to the local broker at that level 0/1 kind of area, or you're going to be sending it up to that level 3. And what's one of the things that I want to kind of talk about here is with these brokers, you can bridge them together. So you might have a broker down at that level 1 that is communicating up to your level 3, that is communicating up to your level 4, that is creating a clear pathway for all these systems. So level 0 is kind of your field network. Level 1 is your kind of control network. And again, this is Purdue model. This isn't necessarily ISA 95, but it helps you frame these thoughts. So I know it might get a little bit confusing, but it's good to kind of figure out where you're going to lay things out. Because one of the key things is, especially in environments when you think about security, is you need to have your Node-RED instance basically as close to these devices as possible a lot of the times, especially when you're thinking about serial or some other kind of, let's say, non-traditional kind of communication. It needs to be right next to it. And that's where FlowFuse comes into play. So FlowFuse can deploy your Node-RED instances, let's say from the FlowFuse cloud, down to your devices within inside of your environment. So level 1 is transforming data from those field devices or from those, let's say, local legacy devices into MQTT. When you move up the stack, you think about level 3, in which you might be doing transformative type of applications or visualization. Whether or not it's going to be saying, hey, I want to convert something from a different protocol. Maybe you're making like a simple API backend to connect to like a historian or some other system to get data to and from. Now, as I mentioned something, I'm going to take a little sip of water real quick. Citizen development. And this is really when citizen development starts coming into play. Because as you have these MQTT brokers and the data existing at these places, and you can have people that are leveraging Node-RED to get that data out and visualizing it, doing transformations and creating unique dashboards that is specifically to their unique use cases that may be only valuable to them. Really, what it comes down to is I think about those times when people export an Excel file from different systems or create some system to collect data, and then they try to do VLOOKUPs inside of Excel. This is a way to start gathering that data in real time. And as you think about the citizen developments piece, you're able to get that data. And another thing I like to talk about is as data goes from that point to point network, as because I was mentioning before, as you move it up from, let's say, the field network to the control network to the manufacturing execution system to the higher levels, you play this telephone game. And if you're very familiar, or if you're familiar with that kids game where usually it's like kindergartners, and what they'll do is they'll whisper a word and with the first kid's ear, and then that kid will take what he hears and whispers it to the second kid, and they'll do that down the line to about 12 kids. And it's usually pretty hilarious to figure out exactly what was said in the beginning and what was thought and translated at the end of the story. With the unified namespace, it really starts normalizing that and makes that telephone game become non-existent because you trust the data and the sources in which it comes from. So just want to kind of give a framework about where these systems physically live. So your MQTT brokers and where they live, where Node-RED's going to live, basically right next to it. So when you think about the main stack, you always kind of see those together right next to each other to basically manage that integration. So I am going to continue on, and I think we're going to be jumping into the demo. I'm going to just do a little bit of a time check, so we're doing pretty good. And perfect. I just pull the chat up to make sure. And so what we're going to be talking about today is an example of a pharmaceutical pill press application. You can think of it as a discrete manufacturing where you have these, let's say, pods of similar systems doing the exact same thing, in which there might be some unique variables that change between each of the systems, but fundamentally they're identical. And what we're going to be doing is we're going to be creating an example which we're going to deploy. I've already got a few deployed already. We're going to deploy a new one. And then we're also going to do some transformation inside of that system. And then we're going to also talk about dashboards and visualization and how that deployment and how you can use environment variables to define that unified namespace or that data model about how that kind of works out inside of your system. So with that, we'll just jump over to the demo. Let me find my mouse. All right. So this is the FlowFuse platform. We'll give a little bit of an overview real quick. And to kind of talk about it. So this is the FlowFuse cloud. And what we have here is we have a team view. And so when you think about it, you can organize your organization into teams. Multiple different teams can function, and kind of think of a way to separate, let's say, just environments. And then from within the team, you have what's referred to as applications. And applications can be thought of kind of like use cases. In this particular case, we're going to think of it as a pharmaceutical line, a pill pressing line. So we're going to be making individual pills. So as I go down, I'm going to go down to my application called Pharma. And to kind of give you an idea here, we have a couple of devices. Right now, I already have one developer device, and then I have three devices in production. So now, when we think about the unified namespace, there's a couple of things that we need to think about as like how it is basically the differentiations between these is the name and the data model for each one of those. So when I look at these particular devices, and again, these are out on the field or out in the line that we're looking at. So when I click on Pill Press Developer, I can now open up and look at this particular device that is using for development and open it up and see exactly what is going on with it. So just like normal, you can spin up and deploy Node-RED instances. And when you think about your flows and so forth, you have basically all the same characteristics as you would have in a normal environment. So let's start from the top and just kind of talk about the data generation. I have leveraged a tool called the data generation tool. If you're not familiar with it, I highly recommend it. And it is called DataGen, and I will share this with everybody afterwards. So if they're curious about how this particular device works, it's basically what I've done is I've created data generation in which we are defining some variables and then we're popping it into an MQTT broker so that we can then kind of start using that data throughout the rest of the system. And then I've also got another one that is defining, let's say, some characteristics about this particular device. Let's say the make and model and things like that, that's going to be unique to that device that might be useful for somebody in the environment. Already deployed, this is automatically running and populating and just kind of sending data into my environment just for us for testing purposes today. Now, I have my MQTT ingestion tool based off of a topic structure in which I'm looking for a wildcard. So right now we're looking at a device and we're pulling in all the data, and I'm going to filter it down based off of what's called an environment variable inside of the Node-RED platform. So the Node-RED platform, it was basically you have what's called environment variables, which you can make unique to each of your Node-RED instances. So with that, we have a couple of ways to do that. So basically what we are taking is I have the environment variable called machine path. Now let's look and see where I define those environment variables now. And I'm going to switch back into the FlowFuse platform. So I'm now looking at devices, pill press dev, and I'm going to switch over to my settings and look at environment. So now I have two environment variables that I've created called machine name and machine path. So when I deploy these Node-REDs instances with these environmental variables, it's going to be pulling those. So to kind of give you an example, this is pill press development. And if I go back over to my application, look at all my other devices, if I go to pill press 1, I also have settings, environment, and now this one's pill press 1. And those are going to be pulled, and so it identifies where it is and where it should store that information within that MQTT data model or UNS data model. So moving back into the Node-RED environment, that's what we're doing here. We're basically pulling that variable and say, hey, I only want the data that's coming from this particular path. And then we're going to be doing some calculations. We're going to be creating a dashboard now to basically identify each of these, let's say, pill presses individually. So if I move over, let me get this out of the way because I cannot see my screen very well. So 1 second, I gotta get to the bottom. There we go. My dock was in the way for webinar. So if I look over here at the pill press dev, I have now created, this is basically a dashboard and created for me to be able to see all this data. So what you can see is we've got the pill press dev, we've got the temperature, we've got some charts, and this is going to be for identification. Maybe I need to do some troubleshooting and I want to basically create a dashboard for the system that's also capturing data, but also displaying information about what this particular application is doing. So I now have, currently I have 4 devices, 1 development device and 3 in production devices. Let's add another production device. So what we're going to do is we're going to click on add new device, and this will make more sense here in a second. So pill press, we're going to call this 4, and we're going to click add. Now what we have is a device configuration in which what we're going to do is now deploy this on my system. And right now we're just going to say that my laptop is this another pill press. So we're going to copy this command and open it up here on the right-hand side. And we're going to click paste and press enter. And it basically now identifies that this particular device is phoning home. Now it says, okay, all we have to do now is run this command called FlowFuse device agent and click run. And now we're installing the dependencies. So that's how quickly it is to get Node-RED installed and up and running. There's a couple of things that we have the device agent pre-installed and npm installed, but as far as everything goes, that's as easy as it gets. You can now see that the Node-RED has started, and we're going to click done here. Click done. And when I click on pill press 4, we're going to see that it doesn't have a target snapshot yet. But there's a couple things that we need to do first. We need to set up the environment variables for this particular device. So if I come over here to settings and I click on environment, I'm going to click add new devices. And I'm going to cheat just a little bit and look over here on my other side to make sure I get all these information correctly. I'm going to add 2 just. And this is going to be pill press 4. And the structure you see for the value is that data model. And then what we're going to do is click Save Settings. And now when I go back over to my overview, we still have not set a target snapshot. So you might be asking, what is a snapshot? A snapshot is a point-in-time backup of my Node-RED instances. So let's move back over and let's take a snapshot of my development device and now push it to all of my new applications. So if I go back over to Pharma and look at devices, I'm going to see my dev device that I've now done maybe some changes, and I'm saying, hey, this is great. I want to save it. We're going to select it and click on snapshot and create a new snapshot and say, deploy to production. And we're going to click create. And then we're going to turn this. Right now we were in device editor mode. We're going to turn that off and click confirm. And we're going to say deploy snapshot to this particular device. And we're going to click confirm. So now when we go over to our overview tab, we can see that we have deployed to production is now our target snapshot for our pill press device. Now, the next thing we're going to do is now, so okay, I've done some changes. I want to now deploy to everything. If I click on the application pharma, and now I'm looking at the application layer. So again, I'll back up a little bit. So we're looking at application. Applications are unique use cases. I click on pharma, and then I click on DevOps pipeline. I now have a way to be able to group or to be able to deploy this automatically for us once we created that snapshot. But there's one thing that we haven't done yet. So in that process, we have what's also called device groups. Device groups are a way to group devices together or applications together. So right now we have pill press 1, pill press 2, and pill press 3. What we now need to do is add pill press 4. I'm going to go ahead and click add that device and save changes, confirm. And now we have those 4 pill presses. And now if I go back over to the, let's say the device pipeline, we should now see that it's actually automatically deployed that new pill press dev or that new snapshot into that particular device. So let's look over to devices and we switch over and we see pill press 4. We now have a target snapshot. And let's go and see that new device that we've created and make sure that everything is functioning as we would expect. So I'm going to click on device editor and open up and say, okay, let's see what pill press 4 is looking at, see how our flows are, see if we're getting some data and so forth. Again, I'm logging into the FlowFuse cloud, and my Node-RED instance is sitting behind a firewall. And to access, the only thing that those devices need is an outbound connection to the, let's say, the FlowFuse platform of port 443. Now we are in the pill press 4 that you can see there. And what I wanted to highlight here is coming in and logging into this dashboard. So in this particular dashboard, if I refresh this page, we now see a dashboard that's been created called pill press 4. We have the temperature, humidity, pill count, spindle speed, and pressure. So let's just say I made a mistake and I'm like, oh no, I don't like exactly what was just deployed to my environment. Maybe I want to roll back or do some other type of changes. And I can go back into my device pipeline and say, hey, let's run this again. I'm not exactly so sure which, let's say deploy to production. I'm going to click on that and click confirm. And now it's going to be deploying that particular snapshot to all of my devices. You can see that process taking forth right now. It's giving me an error right now because my device is in developer mode. So I need to take it out of developer mode for it to finish up. And that's just as easy as going over to PillPress 4 and taking out of developer mode, and it will now take that deploy to production. And there was some changes that I did there. And we can come over here to PillPress, and we can now see maybe some changes of color schemes that I've added and made it look a little bit better. So there's a couple of the things that we can kind of think about. So maybe that transformation of, let's say, for example, we don't really like how this temperature structure is looking. We want it to be in Celsius versus Fahrenheit. That's really easy to change now because I can go to my developed device, do the changes, and deploy very quickly. So let's go through that real quick. We're going to go over to Pharma and Devices, and we're going to get PillPress Dev, enable developer mode, open. Just grabbing something real quick. And so this temperature variable right here, this is which we're seeing on the chart, what we're going to do is we're going to change that to Celsius real quick. So we're going to put a change node in there. And what we're going to do is use a JSON Nada expression. Let me copy that real quick. Get it? Because I don't think you want to watch me do JavaScript right now. All right, perfect. And we're going to click done and deploy. So now we have converted, and if I go back over here to my dev device, so we're going back over to PillPress dev, and you now see that temperature is changed to Celsius. But now we want to deploy that to everything. So we're going to go through this process one more time, and I'm going to select on, go back to my dashboard visualization and look at PillPress dev, and we're going to create a snapshot, and we're going to call this production. Let's say temp change. So we have some idea that we did. What we did, we're going to click create temp change. We're going to turn off our developer mode. And then we're going to deploy that snapshot to this particular dev device. And then if we go over to now to our DevOps pipeline, we click the play button. And now we should say temp change and confirm. And now we have deployed that temp change to all of the devices that are running on this pill. So if I switch over to now our PillPress 4, we can see that we have our temperature in Celsius. So I will pause there and kind of just see if there's any questions, maybe because I have some thoughts and things like that, if there's anything that I can double tap on or have any thoughts before we kind of transition over to questions and answers.
Yeah, absolutely. Nothing to add there. That's a really great presentation.
Right.
So maybe we can jump right into the questions.
Sure, absolutely. So, so one of the things I was I'm going to stop my share real quick. So one of the things that I mentioned before was the telephone game. Do you find that sometimes that's something you see your customers or that the data and the trust that they find with leveraging, let's say, the unified namespace? Do you find them to be more trustworthy and being able to use that data in ways that the legacy ways of that point-to-point communication that may get them in trouble at times? Have you had situations or examples like that?
Oh yeah, absolutely. I mean, so as I mentioned, in most cases, it works. So a lot of companies will say, I don't probably need to have a unified namespace for this, so I could connect stuff up, and it might work up until a point, right? As soon as you start to want to get this data out and scale your solution, this is where kind of like they hit like a roadblock, and we get a lot of customers coming back and say, okay, now it makes sense. So again, the unified namespace is a concept that really starts to make sense at scale. So if you're just connecting to a few devices on a certain section, by all means, you can connect directly point to point. But as soon as you start to scale, this is where you start to appreciate the power of the unified namespace, being able to plug in different systems, and also the idea of using MQTT, like an open architecture. That's also one of the things that is super powerful, because what you want to be able to do is you want to be able to pick some best-in-class tools and be able to try them out. So for example, here right now, if you are plugging in FlowFuse into your unified namespace, you can use all these open standards, whether you're using OPC on the other end and MQTT on the other end. It's easy for you to really plug FlowFuse or different Node-RED instances and try and start to test all these different ideas, of which if you had some proprietary application that you're using, it's really hard because you have to stick with what's compatible with whatever device or software we're using, which really limits the innovation that you could really perform. So this idea of being able to plug in different systems, it's really powerful.
Yeah, and I think about what happens when that knowledge of the structure of that point to point and how things are connected, where with the unified namespace and sending data in, it's very much easier to trace down the source data and where it comes from versus where I've been in situations where I've been I mean, an example for me is I was creating dashboards and visualizations from data that was more raw data down at the lower levels that at one point in time was competing with business intelligence because they were using the end of the data structure. And so they were creating dashboards and visualizations that the numbers, at the end of the day, weren't matching 100%. Were they wrong? No. Was somebody more right? Probably, but at the end of the day, it's what I've found, and as you do this transformation into this transitioning away from this telephone game, you will hit conflict, and conflict is good because at the end of the day, you're going to be working from better data at the end of it. But let's jump over some questions that I see kind of popping through. Um, where is my questions? So, can developing happen on a physical device so actually inputs can be used to make programming changes? I'm assuming this is for FlowFuse and Node-RED, and absolutely, you can develop directly on that device. And that's what I was doing before. Is essentially, if I think about all those 4 pill presses, one of those I could say it's the dev pill press that maybe we're okay with having some off quality or some changes, and say, okay, this is where I'm going to do my development. Do those changes so it's communicating directly with the machine and using those environmental variables to then basically configure it and then deploy. And maybe you want to do like a staged deployment. And that's what the benefits of the DevOps pipeline is. You can say, I want to deploy to one machine or one group to make sure everything's working, and then I'll deploy to the rest of the 100 groups. So yes, definitely that's one of the benefits is being able to deploy or to develop directly on the device. Can you please comment on how to approach your ERP teams and Oracle and prepare for them for what is needed for them when creating a UNS architecture? ERP is heavily embedded often, so how do you prepare them? This might be a better question for you because maybe.
Sure, absolutely. Yeah, so I mean, the most important thing is first of all to kind of like really just prepare the ERP team from a cultural perspective to make them understand that the old way of connecting an ERP system to an MES system, for example, really leads to this tightly coupled architecture that is really not so scalable. So if you change one thing on the MES system, if you change some database arrangement on the MES system, it affects the ERP system, how it communicates with the MES system. So this tight coupling really makes it hard for you to actually share information in a scalable way. And then rather to think about it as the ERP publishing this information into an MQTT broker for the MES to consume that information from the MES, from the MQTT broker or the unified namespace. That way, there is the abstraction where the MES doesn't really need to know the implementation of the SAP of the ERP. So whether it's SAP or Oracle, the MES system simply consumes information from the unified namespace, irrespective of where that information is coming from. So that shift in mindset and starting to look at it that way, it's really a good way to prepare them for integrating ERP systems into the unified namespace, and also just kind of like identifying all the different data that needs to move into the unified namespace. If is it do you need to have some gateway? So it could be a Node-RED that is using an HTTP connector to connect to the SAP, get the data that it needs to get out, and then publish it into the unified namespace. That kind of way of starting to think about how to get data out into the unified namespace. I think that's a good way to start the conversation with the team.
Perfect.
Yep.
So we got a question here, maybe for me, is SCADA and DCS systems offer loads of data in significantly fast manner. How does FlowFuse scale on the edge for transforming, let's say, OPC UA to MQTT? So there's multiple different ways of kind of how you would think about that. And so, when you think about the scaling aspect, if you are looking for high availability, and that is truly a concern as the volume of data, FlowFuse, if you deployed it, let's say on-prem next to those environments, you can have high availability on a Kubernetes cluster so that you can expand indefinitely and make sure that you don't lose any of that information. But that's traditionally not really that big of an issue, and can do that transformation, no problem. And at the same time, whether or not you're leveraging, and I'm not trying to say whether or not you should go directly from, let's say a Siemens SM300 PLC with a specific communication to capture that data, or that DCS system. There's just ways that you can approach it to make sure that you always have that data retention. I don't know if you want to take one of these. In the UNES diagram, the connection from the broker to the historian is bidirectional. I understand the direction from a broker to a historian is for storing PLC data. What is the use case for historian to broker data path? Would you use a REST API like a service consume historian data for further analytics be more efficient after the data is already available in the data historian? Do you want to take that one, or do you want me to?
Yeah, sure. Yes, I'll take that one. So yeah, so you're right. So typically you've got your data flowing from the unified namespace into a historian, and then from there you could then perform further analytics. But there's cases where you want to get some form of snapshot or some data point that might be useful if it lives in the unified namespace. So for example, you've run a query to say to find out what was the rate of production between this hour and that hour, and you want to put that hourly rate of production within the unified namespace for context, right? So this is where you then plug into the historian and then pull that data out and then publish it into the unified namespace. So you're not necessarily publishing the whole historized data, but just those queries that you think might be useful for consumption into the entire enterprise. And then this is basically where you connect on the other end using a REST API and then publish it into a unified namespace using an MQTT broker. So again, if the historian is not capable of communicating directly using MQTT, this again is where you'd put FlowFuse in between your historian and the MQTT broker. The historian will do the REST calls and then publish that data into the unified namespace.
Perfect. Next question is just wondering if the UNS is embedded into the MQTT message, or is the topic structure, or does it use both? I'll let you go for that one.
Yes, I'm not sure I understand what York is asking there. I don't know if you want to unmute him if he wants to maybe expand on that topic.
Just give me a second so I capture how to do that. I have not done that before. I normally know how to do that, but I apologize. If
Okay.
I
All right.
look at that, basically I'm understanding is just wondering if the UNS is embedded into the MQTT message or is it the topic structure? And if my understanding is, if I understand the question correctly, the UNS is the topic structure for the data model and how that, and for example, if you're leveraging Node-RED, the topic is the data model, and then the data underneath it is whatever you're kind of publishing to that.
Okay. Yeah. So again, if that's the question, then uh, the idea is that it's either you reflect unified namespace in the topic structure or in the MQTT message itself. So we've seen some people that gone down the path of embedding the unified namespace structure in the payload, which in a way kind of like defeats the purpose of the unified namespace because you want to have that semantic or hierarchical access of the data. So you want to reflect the semantic hierarchy in the topic. And additionally, if you put the structure in the message itself, what it means that you're now pushing the burden to the consumer of that message to go through all the different payloads that it receives to find out where they are coming from, instead of just being able to use the topic to reference. So you're putting like a load on the clients for them to figure out where the information is coming from.
Perfect. Next question is we're using Kepware as a gateway for setting up UNS to need to push data from an OPC UA client to MQTT. Any thoughts on combination of both? I have 15,000 tags in Kepware, and I'll take this one. So really, when you think about that, that's a lot of tags. And you would really, from a UNS standpoint, is are you going to just be putting everything? Because I think you're going to be missing a lot of the value of as you kind of have to prescriptively go through these and each individual ones. I think that's if you're going to just be blanking, I think you're gonna struggle with maybe some of the value propositions of the UNS right off the beginning. But at the same time, there's multiple ways of capturing that data. For example, I want to say even Kepler has a gateway connection to MQTT within, so you could send it over to, let's say, a HiveMQ or your UNS gateway system. So I don't know if you want to add anything to that, because I
No, that's perfect.
perfect. Okay. Um, how does relate your approach of UNS to a PC UNS? So again, I'm not necessarily the expert in necessarily kind of thinking about the OPC type of UNS, so I think that might not necessarily be a question unless Kazai, you want to take that one.
Yeah. So again, I'm not too sure I understand the question, but maybe the idea is that how does OPC fit into the unified namespace? So basically, the idea is that you've got your OPC UA being used for closed loop process control, right? And then if you need to integrate that data into the IT, this is basically where you need to convert that OPC UA message into MQTT. So basically, this is how you bring OPC UA data into a unified namespace.
So in Node-RED, if data changes incoming on MQTT, what is the best practices to set up change history log in time series database for raw data analysis? So if I interpreted this question, it's basically saying, how do I interpret the change of that data? And ideally, you would probably be creating a separate tag and storing that data as a different structure or a naming convention that is associated to that. I don't know if Kazai, you have thoughts on that.
No, not really. I'm not sure I understand the question, right? I'm not sure I understand the question.
Maybe
So what is the best practice to set up change this log in time series database for raw data
I
analysis?
I
Yeah.
figured out how to allow to talk if you want me to see if we can allow him to talk real quick. Okay, est-ce que you can Ekashe, I think you can speak now. Right, I don't All right. I don't think he's come. So, let's just go ahead. And I think actually we're getting pretty close on time, and we really want to kind of wrap this up to just about an hour time. And I do know that there's a couple of things we might want to show, but is there anything that you would like to add or any follow-up thoughts?
Yeah,
Maybe
so just to
as far as
say,
like, yeah, go ahead.
oh, yeah, absolutely. I mean, just to say, if you want to get started with maybe connecting FlowFuse with HiveMQ to test up this POC or prototype, so you could use HiveMQ. If you go to hivemq.com, you could use our HiveMQ cloud, which is a serverless managed instance that allows you to connect up to 100 devices for free. So that would be like the best way to start experimenting with how you could connect a FlowFuse and MQTT to build a unified namespace. Or you could simply download our enterprise broker that is free also to try with a limited connection of up to 25 clients.
And I'm gonna share my screen just one last quick second. So if you are curious about trying out a FlowFuse, please feel free to sign up for a trial. You can look at self-hosted and or book a demo@flowfuse.com. But just want to say thank you, Kazai, for joining us today, and appreciate your knowledge on the unified namespace and really helping out everyone that joined the webinar today. Again, this video is recorded. We will have the video available up on YouTube and up on our website after. So thank you much. Thank you everyone for joining today, and look forward to seeing you guys on future ones.
Thank you.